Okay, from Krieger to Debris. I'm Dierk Ohlerich, also known as Chaos of Farbrausch. And I want to talk about what we have been doing in the demo scene for the past couple of years. And it all started with a competition. In this competition you had to do the most amazing audio-visual presentation in just 64 kilobytes. That was our goal, 65,536 bytes, and not a single byte more. And back then, before the year 2000, what would you imagine is possible in just 64 kilobytes? Maybe you can only do simple things. Back then, 64 kilobyte demos looked like this: simple forms, simple blobby textures, lots of abstract stuff, and more abstract stuff, because one couldn't really put textures, geometry, music, and animation in 64 kilobytes with making it look real. But after the year 2000, we started with the procedural content generation. We at Farbrausch, and later, well, almost everyone. And from that moment on, we could go one step further to reality, just in 64 kilobyte. Obviously, the first attempts were far apart from reality, but we were getting there. And as we moved forward, this is from conspiracy, we got pretty close. But this whole 64 K thing, well, we want to do some step more than just doing a 64K demo. We wanted to make a game in 64K because we thought, well, that should widen the audience of people who are interested in the stuff we are doing. And we figured out that 64K is a little bit too less. So, I messed it up. Sorry. How are we going to do this procedural stuff? What do I mean if I say procedural? A very simple procedural thing might be like this. I have this Perl noise function, and instead of storing the image of the Perl noise, I store the program that is needed to create the Perl noise. And you see all these parameters are a lot less data than the Perl noise itself. Of course, this image is not interesting. If we want to do an interesting image, we need to write a lot more code. Actually, the code for this picture doesn't fit on the screen with a font size of 1 point. It fits. And it's all these little things. Of course, we don't store the ASCII text. We have much better compression schemes for storing the stuff, but this just gives an impression. If you combine many of these simple functions, you can come up with a texture that looks realistic. And as I explained earlier, well, intros alone wasn't enough for us. We wanted to make a game. We wanted to show everybody that you can have a game in 64 kilobytes, and we failed. It took us 96 kilobytes to make a complete game. And this is again the number, 98,304 bytes for all the code, all the data, everything which is in our game, which is called Krieger. With Krieger we started our thing was doubling the K in names. From that moment on, most of our stuff had 2 Ks. Anyway, Krieger. During this progress bar, of course, all the procedural generation is done, all the formulas are evaluated to create the textures and what we need in the geometry. And let's have a look at the game. Do we have sound? Please tell me there's no sound coming out of this box. So we have to play the game without sound. So this is basically released a few months before Doom 3 was released. We wanted to make this deadline at all costs because Doom 3 had all these cool stencil shadow effects. And we wanted to show, well, we can do it in just a tiny amount of space. Oh, they're trying to kill me, this is not good. We have sound. It is a little bit hard for me to play this because I have a very bad perspective on this. I have to start shooting earlier than I thought. Some miraculously they died. I need a bigger weapon. I need a bigger weapon instead. As a game itself, it's not much fun, it's very buggy, but as a tech demo, it's fulfilled all its purpose. I'm not going to play this through, of course. I use all the sheets to show you the fancy stuff in it. Well, I think I killed myself. This is one of our... Oh, this guy is nasty. Something's very wrong here. He shouldn't be out there. Well, I'm telling about Buggy. We made special weapons. This, for instance, is our light weapon. It is used to shoot light sources around to highlight the wonderful shadow effect. But we thought if we have a light gun, well, it's not a gameplay feature, it's more fun to watch the shadows run around the corridors. With that, we also should have a shadow gun, which is on this key. It shoots around shadows. Which is even more. You see where our main reason for doing it wasn't to make a cool game, but to have something to show off. And there's one especially interesting part, which is unfortunately guarded by this obnoxious monster that is here. This shows really nice display. All these textures are, of course, generated procedural, like all the geometry, everything you see here. And the cool thing is that we see here the procedure for generating the distortion of this round thing rotating of the cylinder can also be used to change the materials, all free for the procedural attempt. This is the end room. The shadow gun was specifically engineered to light this room in interesting ways. And it's coming back into the third slide. One more thing to show. To restart, get back to some simple spiders. Don't kill them all, you want something for demonstration purposes. Here they come. The spider can actually walk the terrain and the steps will never moonwalk, and he's, well, semi-intelligent in where he's going and how he's doing it. Very semi, of course. But he can pass some strange terrain and usually doesn't get stuck without killing. So we spent some effort in making things walk in a realistic way. And of course they have 3 legs because that's cheaper than having 6 legs or something. This is back in what is like 2004 or something, just before Doom 3 was released. So much for our attempt to write a game, which we failed, and our attempt to write a cool tech demo, which we did. So how did we do it? I go back to the concept of procedural texture generation, and we've seen here, well, everything is done procedurally in this demo, but the textures are the best example. First, because our texture generator is really good. Our mesh generator is medium-core, but our textures are cool. Of course, you don't want your artist to type a program like this. Actually, this was our first attempt, and we said, okay, we need to write a user interface for creating this stuff. The user interface looked like something like this. You had the image you are going to create on the top, and in the window below you could type where you can type text and write a program. And I thought, well, this might be a little bit hard for the artist, but I can implement it very quickly. Unfortunately, it was a total disaster. It was so unusable. Even I, as a programmer, didn't want to use it. So we had to come up with something better. The next attempt was something like this. We didn't program this one, but the idea is, you see, this is 3 operators with lots of sliders, and you can just pop in operators there, and they will all be executed top-down. And you have all the sliders. I think the art by texture generator works like this, but this is too limited. You can only have a stream of operations from top to down. What we need is a tree, where you can have something like this. This is what most tree editing softwares look like. You have these boxes, and these boxes are connected with arrows, and then you have the sliders. You click on a box and you get the sliders up over there. You can change the parameters. You could also integrate the sliders in the boxes, but then the boxes become really big, and we don't want that. So this is actually what most people do. And if you followed the talk from the 4K stuff, Mentor, I think, this is what it looks in an advertisement prospect where you show how cool your software is. This is how it looks in reality. It very easily gets pretty ugly. So what we really had to do is get rid of the arrows. And I came up with the idea, well, if 2 boxes connect to each other, then there's an implicit arrow from the top to the bottom. And you can see how this resembles the same structure, just without the arrows. And this is what we did. And now let's look how this looks in reality. So let's go to the workflow. Again, our double K fetish. Here we have a very simple texture. I prepared it just for the demonstration. It begins with a flat square. And if I press here, I can show it. And if it has this green line, which you might be able to see, that is the one operator which is shown. Oh, I think texture quality 25%, no. So yeah, now I have some dots. I can blur the dots. This is not a spectacular texture. I invert them, create normals out of it, and have a bump map thing. And I have here, this is very hard because, can you imagine how distorted the image is for me doing it? It's very hard to point. Anyway, you can change the direction from where the light comes and have this bump effect. And from very simple building blocks, you can build all the texture complexity you've just seen. This is our palette. These are the texture operators we have. Well, 3 or 4 dozen of them. Maybe 24 really important ones, and then a few really crazy ones for special applications, like bricks. Yeah. Where do you see it? Is this here? Yeah, this is the next thing. We have very simple operations, and therefore we need lots of them. Like this is some kind of bird's eye view, and there are some more complex pages, and some even more complex pages.
Yep.
And
I was asked to repeat the question.
there are lots. Yes. Lots of pages, so don't be. This is Krieger, just to give you an impression how many operations it takes to make a whole game. So now.
Okay, sorry. Mostly I just wanted to Like maybe there's just a cute joke with the name of the castle, Return to Castle Pillipala. I wanted to know what Pillipala is.
I don't know. I didn't do the art. We are a team. There's me, there's Rück, there's Fiverr, who actually built all these operators and invented all these wonderful names. And if you want to know what Castle Pillipala is, my best choice is just to show it. Maybe it's something which didn't make it in the game. And this is Castle Pillipala, if you want to know.
Okay, sorry. I'll let you get on with it.
And it's definitely in the unpublished chapter 2. This is a shame we made so much stuff and most of it never got used. Because we failed to make a chapter 2. Well, so much for Castle Pillipala. But it's a German phrase for whatever, bullshit. Let's pick something which actually made it into the game. There's one more thing I have to explain. This OR is a tree structure. But sometimes you need to pull wires. And when we need to pull a wire, we don't do it by having a visual wire, but just by making some kind of, by naming an operator. So this loads wherever 101 respawn is stored. Here we store it, and then some kind of invisible wire goes down from where it came from. This is here. We could draw a small line, but we don't do it because these lines are just, well, everything will be again filled with lines, and this is exactly what we don't want. But actually, this store here connects to this load there, and actually it's a respawn points definition for the game where you respawn if you die. And so everything can be connected in a much more complex way than a normal tree. But the cool thing about operator stacking is that 90–95% you need a tree. And we have a very compact representation of a tree. And the 5 or 10% where we actually need a graph with a real link going somewhere, then we have this load store mechanism which hides all the wires and just gets you to the right point. So this is one of the woody sections in the whole thing. This section, and again, the section is made of, you see here, there are several parts which get added, and these parts are this part, and this part, and this part, which is behind the camera, and this is a room behind the room, is also in here, and all these parts are just added to make the final room. I'm just trying to find this wall here. I found it, and this is of course made up of several things. It's loaded from somewhere. Where is it? Here. This is a wall. And this is also made up from individual segments. Most of them off screen at the moment. I wanted to have this wall section. There's a wall section, and this is actually some primitive finally. You have a cube, you bend it, transform it, assign a material to it, apply the correct mapping, UV mapping, put it in the right place, which is here. And this is added with the wall segment, which is also just a cube. Cube somewhere. Cube. Apply UV mapping, wrong mapping, right position, multiplied by 2, add, well, this is the material, where does the material come from? It's stored somewhere here, I can go there, this is the material, with all the parameters we need to define the material. Most important one is of course the texture, here's the texture, this is how the texture is made. The texture has many layers. I don't know why he needs the rotten stuff on it, but I'm sure it adds something to the final image. You can see it. It's not unimportant, it's just subtle. And if you fiber builds these textures in a very chaotic way, they are spread from everywhere. I hope I will find the place where the actual wood does come from. Yes, and here this is the part where he makes the little black dots. Of course, the dots should not be where the holes are, because the holes usually don't have these dots. Go back. This is the main wood texture, which is just some pollen noise transformed. And whatever he does to make it look cool. These are the holes. And this is the distortion for the holes. If I'm lucky, and if this computer is really fast, this is a section. Now I have to find the damn wood again. Where's it blinking? Can somebody point me where it's blinking?
Lower right.
There. Okay. If I just move one of these holes here, should be able to see how the texture changes. This is unfortunately not real time, but you see the potential of changing one part very, very deep in the hierarchy, while previewing another part in the complete, how it affects how complete scene with all the lighting, the texturing applied. Yes. Another thing about this user interface, you see there are really lots of operators, so we tried everything to make these buttons as small as possible. Demo settings? No. Editor settings, yes. We also have large fonts, but nobody uses the large fonts. We want to have the smallest fonts. Some people even hide the scroll bars because we don't really need them. Just to have even more space on the screen to get all this done. Back then, nobody had an HD monitor. Another thing, how did we do the animation? We have these robots walking about. And this is actually the small robot, this one. And up to some ground plane. No, we can't up to something. Enabling the walk operator. And here we have somebody. And he's ready to walk. Just give him a position where he should go. Start the time. Where's the function keys? And he will walk there. And it is not working. Maybe. Okay, this is not working, unfortunately. Well, that's good. You've seen it in the game. It does work if you use a workflow which is a few years older. Maybe you make it be hacked it. Although everything is done procedural here, it is always good to have compression. So, apart from having all this procedural stuff, you need, of course, if you zip it, things will get even smaller. And zipping is not good enough, because we want to have the executable which contains all the data, to be the only file in the distribution. You don't want to have a zip, and then you unzip it, and then it's larger than 96 kilobytes. So we must have the executable itself being 96 kilobytes. So we made something like a zipped executable. When you start it, it depacks itself, but instead of writing the depack result to the disk where you have to start, it directly starts the depack stuff. And our packer has two stages. So there's one disadvantage about this technique is that most virus scanners see that you're doing really weird stuff to crypt your application. And they warn you, this application must be a virus because it's doing exactly the same stuff a virus would do to hide itself. So the 64K intrusive or 4K intrusive, you'll always have torturous virus scanners who think you're just trying to sneak in some malicious software. It looks very suspicious what we're doing, but we have to do it to meet the size limits. Our multi-stage depacking goes like this. First, we depack only a small, with a very small depacker, we depack the very good depacker, and the very good depacker depacks the rest. And there, just because if we wouldn't crunch the very good depacker, that alone would be too much size. One of the most important things when going for a small size is to reorder the data in a way that fits well to a packer. So what you're trying to do is you make a transformation on the data so that it looks nicer to the depacker. And to use the data, you have to make the reverse transformation to actually be like it was before. And what you are hoping is that the size of the code needed for the reverse transformation is actually smaller than the gain you get from the transformation itself. Actually, the transformed data may as well be longer. If this longer piece of data packs well, then it's worth the effort. And some very simple things to do is sort the operators not in the order which they are executed, but in the order, sort them by type. Have all transforms, then have all purlins, then have all blurs, and go so on, because similar operators usually have similar parameters, and the packer can just feast on all the similarities and pack it a lot better. And actually what the second stage of the depacker makes is it treats the code as data and does transformations to the code. And these transformations involve actually disassembling the code completely and finding out what the instructions do, and for certain instructions there are certain transformations which make the result in the code quicker. And of course this transform code can't be executed, but we have to redo all the transformations before executing, and that's the second stage depacker. And that's so long that it has to repack itself. Okay, let's go. So we did the game, we wanted to go back to the intro scene, and we thought, well, we have all this amazing technology. Let's make something really cool. But we felt we can't make it as cool as we want if we have the 64K limit. So we said, well, don't care about the limit, just make it as large as we need it. And we ended up with this number, 181,248 bytes, which is not a special number in any way. It has no appealing prime factors, or it's not the limit for any special competition. It's just, well, we ended in our process, and I'm pretty sure we could get it down to 144 kilobytes, maybe even lower, but, well, for the demo scene, 64K is the limit. And if you're 65K, then you're not 64K, so it doesn't matter. And for everybody else, 144K is just as good as 178K. We could spend months of tweaking and optimizing and redoing data, but hey, it's good enough for what we wanted to achieve, and it will never fit in 64K anyway, unless we redo it completely in a different way. And this would be the moment to show debris. which is done over there, and I didn't give them a signal so that they can prepare. Actually, it takes a while to do all the compression. One very nice thing about this packer is the more data you have, the better it packs, because the packer can find more and more and more and more similarities. So it's always good to make huge productions, then the packer will pay off twice. This also is the moment to introduce the team. It's not that I did it all myself, no way. There we have Rick, that's the second coder, Chaos Me, also second coder. We have both of them. You have KB up there, he did the synthesizer. United States of America, also known as Fiber, he did most of the graphics. Gizmo did some more graphics. He did the music. Wayfinder did the sound effects. Ron did the music, Wayfinder did the sound effects. Yeah. And the direction is what we want to see the logo for. Okay, let's go into the debris data file. It's similarly large, but it might have to do something with the fact that most of the Krieger data is still in the data file. It was never completely cleaned up, so it's just 2 demos in one data file. Some textures are reused, and, well, too many operators won't hurt the system. Let's go to the timeline and find the thing I want to explain, 929. This is where we do all the cutting. It looks as if we were diverging from the pure do everything with operators thing, but this is just another view to operators. It's just an operator displayed in a more convenient fashion. It should be somewhere where we blow up our competition. This is the credits phase. So they just actually it worked. They were blown away, but they struck hard. And again, this scene is made out of many parts which are just added together to form the whole thing. So let's see how this blowing up stuff was made. This is just blowing up. We have here 2 different names to blow. And it all starts with the 3D font. And if we go to wireframe, we see this is an American keyboard. Wireframe. We see that it already has a very interesting polygon structure, and Fiverr thought, well, if I just take this and blow it up, it looks fantastic. So we have to do something with blowing up fonts. And this is how the whole credit sequence was done, because this structure with these long and less long and small parts is just perfect for blowing up. And here we have the explode operator, which does all the explosions in the whole demo. And the explode operator has a few more parameters. It's one of the longest operators, because there are so many variations of blowing things up that we had to care about. It should stop now, just. And since it's all pretty much real time, you can just change the font. And have that fall apart. Yes, font. And so it can. The physics, of course, for this wonderful, perfectly calculated stuff is all fake. It's just a random rotation of Euler angles. Rotating by Euler angles gives very confusing, annoying rotations, which is perfect for some things like this. And the position is just a x squared plus x thing. A parabola, or whatever it's called in English. And this gives pretty, it's good enough for what we do. There must be somewhere gravity. Here there's gravity, and so it will fall down however I want it. Another very good thing about not doing a real physics here is that I can stretch the timeline. And going backwards with the physical simulation is always very difficult, but if you just fake it, it is no problem at all. And there's one thing that Fiverr really hates, is when the camera goes through some solid object. So it must be all very deterministic, and all the camera paths have to be moved in a way that they don't intersect with something. And so this is a very important feature for him to do the correct camera movements, preventing the dirt. Another important scene is the diver. That's 185. Up here. This is takes a bit. He's now generating almost the whole city, because this is in a city setting, not just in the small parking garage. That takes a little bit longer to calculate. This is why I wanted not to do this presentation on my laptop, but on this computer. And if you're very lucky, it'll crash. There are always issues with the memory constraints. F5, and here we have the bridge driving through the street. And this is like the real movie world does it. It only works from this perspective. As soon as I move the camera somewhere else, you see how cheap it is. This is not impressive, is it? I'm especially annoyed with this flickering, because it's a free giveaway that is going to blow up. But they are time constraints in demo making. This is very cheap. It's like a film set. Don't look in the wrong direction. It doesn't work. But it works in the final, just from the final perspective. It's just what you would expect. And another thing which was always something people really liked about Debris is the camera movements. You see all this shaking and stuff. And you can well guess what the shake is doing. This is the shake operator. If I bypass it, this here means that it's bypassed. The camera doesn't shake. Actually, the camera is doing nothing at all, except a few well-tweaked parameters for the shake operator, which in the shake operator itself is also very simple. It just adds sine waves to the camera position and rotation, and different layers of sine waves, and it's all. So most of the camera movements are basically built like this. Here's another one. Fiverr left it bypassed. Let's see what he didn't want to. Another shape he didn't like, so he bypassed it. One of the cool things about the werkzeug is if you have if you tried out something, you can just, you don't want to just move it aside, plug in something different, and see how that is. And it's not lost, it's just there, it's unconnected, it's rare. But it's not lost. If I really want to go back to that, I can just plug it in again. I don't have to rewire every connection, I just move it around. If you look at these pages, there's always thousands of things which are just not connected. This is the camera supply, and you see it's empty. Here's some other supplies. What did Fiverr want to do with this? It's doing nothing to, anyway. This one is pretty bad. I guess I knew what he was supposed to do. This is our original shape. And this whole thing. This is much better than making spline with all these wiggly movements. If you look at it this way, we wrote our own tool which contains a painter, a modeler, an animator, and a cutting tool. And since I did all the user interface programming, this seems like a big job for somebody who does it in his spare time and doesn't get anything from it but reputation. But how we did it was, we have one tool. Just this dragging around operators, changing parameters. I only had to program one tool to make all these different things work. And this is the only way we can do this kind of things in our spare time, just to break it into simpler things. All the textures, all the modeling, all the putting together scenes, the animations, all done with the same user interface, which is this user interface. Well, this is of course the timeline, but again the timeline is just the simple view to the same operating structure, which is used for everything else. Okay, there is a spline editor, but it's a very crude one. This is a miracle of how we managed to work with it. And the other thing that we achieved with this kind of tool is the total integration. Every aspect of this demo has been done on this tool. So, as I showed you before, with changing the texture and seeing it in real, or not just real time, in the finished scene, you don't have to switch tools. You don't have to change the texture somewhere in Photoshop, import it back into the scene, or go through an export process for the meshes. You can just change something here. You have total control from one position. I think Trixter is going to talk with a whole talk about this topic, how cool it is to have nice tools. So it is even great to have a tool like this if you're not going for the procedural content generation. If you're using prefabricated 3D models from Softimage or Maya or whatever, if you're using textures from Photoshop or your digital camera, you can just import everything into a tool like this. Of course, then you lose the size advantage, then you won't fit into 64K anymore. But you can just import stuff and build the demo in such a tool. Building the scenes, building the world, adding the procedural content where it's better to use procedural techniques, and using real-world imagery where that is the right thing to do. And that basically was my talk.
Any questions for Chaos? I'll go with first the maps in the back.
Here it is. Wireframe. We think that. Actually, what the explode operator does in addition to adding all the animation stuff is it extrudes every polygon into a whole cube-like thing. And the problem if you do this, if you just have a face and you extrude it, then if you have two connecting faces, you will get all kinds of weird artifacts in the middle. So we don't just extrude the back, we also make it smaller, so that some kind of prismatic forms are created.
And do you connect triangles into quads? Something so it's
yes, this is one advantage of our mesh format, that we usually have the correct simpler model. Okay, we don't do it for the fonts, because the fonts I don't generate it in that way. But if I use a cube, yes, that is the best example. Here we see the cube. And the mesh structure knows what is a polygon and not only what is a triangle, so that we can correctly extrude this cube to the inside. I move it to the outside, that is more visible. No, I can't move it. But you see here how there are some polygons are created in the inside of the cube. And how we make them smaller as they go inside, but if we don't make them smaller, you will have Z fighting here on this face, because there's also the other face and the face where it came from. So we have to just move it a little bit inside with this option, and then it won't Z fight. Maybe it is here you have the set fighting, that's ugly. And just bevel it a little bit into the inside and everything's fine. And then it can be blown up.
This button.
No, I don't want to do that. This is a nice way of showing it. I think now it's very obvious what we're doing. Yes?
Yes. Can I ask another question? You talked about that Shaco operator for your camera.
Yeah.
Can you tell us how it works?
There is not much to tell. It's a little
Well,
bit.
there is, because you can say we're moving the camera, let's say left to right, fast, or we've went into the timeline.
We add sign to the rotation and the position. That's all.
Okay, is it procedural or is it handmade?
It's a sine curve.
Just a sine curve.
Just a sine curve. There's also a ramping function so that you can have it.
So many sine curves added or multiplied together, basically.
I don't remember. It's you have a shake event here.
I ask you because I've tried so many things to reproduce that and everything fails. So maybe there is a secret.
There's no secret. Actually, we had a discussion with Fiverr. We really had a fight. Fiverr wanted this perfect shake operator, and I said, all I can do is simple sines. I said, no, I need something better. And I gave him simple sines. And it did work, luckily for me. I think, how's it working? It's just one sine. You see frequency, amplitude. Frequency, amplitude. There's ways to animate it. Somewhere here must be, it is not animated, but you could animate it. And
it says Perlin right under parameters. Are you actually using noise?
Here are some more options. Yeah, we actually use color noise. Well, the screen is so big, you see, it's very distorted for me. What we have here, sine or Perlin. Okay, that's a trick. Thank you for remembering me. And this is how the cameras are rotated, how the matrices are multiplied to each other. And this is fade in, fade out smooth to make it more interesting, to make it fit as a scene. So okay, it's color noise, not sine. But well, it's as simple as sine.
Hey there. One of the things that a lot of discussion happened when this absolutely beautiful debris demo hit was its comparison to Proceedural's Dark City. And I was wondering, in the case of a project like that, is it something where they say, hey, we've got all these really neat knobs and what can we do with it, and then it kind of moves into it and ends up looking like it's looking, or is it a case of you plan ahead of like, how can we do a city that explodes?
There was a substantial amount of planning in this, and there were a lot of influences in this. Dark City is one influence. Even worse, there were things coming out that are very similar, which were not an influence, and everybody thinks, oh, just ripped that off. Like this French movie with... maybe. So some things, this is a heavily influenced demo, this was a heavily planned demo, and the whole sequence, the whole second part, where we rip apart the city, when I wrote the explode operator, it was specified for just one thing. We wanted to have the ground come up. This was in the original script, to have the ground come up, especially for the last scene and for the bridge diver scene. And, but then Fiverr found out that you can go up anything. And he did it. And the whole second part, with the city going anywhere, was never planned, and it was not realized afterwards. it is actually, we've been working with this very long, and we were at the point, if we don't release it at breakpoint, we'll never release it. And it was a very, very tight fight to release it in the end, because we had all sorts of problems with this demo. And so we were just happy to have a way to blow everything up and then read on.
I'm kind of curious, does your tool generate interpreted code or is it compiled code?
No, it's a data structure. I wouldn't call it an interpreter. It's a tree. We saw a tree and we traverse a tree. And for animation, we have some kind of very simple interpreted expression evaluator. But I wouldn't call it a virtual machine or something. We saw a graph, of course, not a tree.
Just for the fame of it, can you tell the story about the music in this demo? Because I think nobody really knows that.
That is a very annoying story. We had the biggest problem was to find the right music, and the music was finished on the party during the party in well some place where only party organizers have access to, and it didn't fit at all the first drafts, and in the end, Fiverr was very nervous about the music, and he said, okay, I don't listen to the music before the competition. And so when the competition was shown on the big screen, it was the first time that Fiverr heard the original soundtrack. And actually it did work, so we were all happy. But it was very tough getting there. This is a problem with Fiverr. Almost everything we do almost kills us. It's the same with Krieger. It was a multiple years process. When I say I worked 5 months on a demo, I say it's a very short amount of time to spend on a demo. That was FR8 was like very like flash. Oh, we're done. It's only 5 months. But for Krieger and for Degrees, there was some serious pain going on and getting it done. And actually, we thought, no matter what happens, it will never be worth the effort. But it was. That was the most amazing thing. After all the pain, after all the time, after all the labor, it still was worth the effort.
This should probably be a personal question, but have you thought about using a stack instead of tree?
It's a graph, not a tree. It's mostly a tree, but with this load and store, we can turn it into a graph. So it is technically speaking a graph. Just the editor looks like a tree editor because tree editors are so much easier to program and use. So it's a graph, and I wouldn't know any other data structure to use than a graph. Actually, this is very important, as you have seen with the 4K talk. The graph allows you to reuse things. And it's all about reuse.
Thank you very much.
Have you ever considered using your particle system for liquids?
Yes.
Have you?
This is a strange question for this talk, but actually I have on my computer, which is not here, a wonderful particle system used for liquids. And I'm waiting for the right demo to release it. And I wrote it 2 years ago, and it was too slow, but now it should be running fine.
You don't have that on that computer?
You should meet me afterwards. Yeah.
So I have sort of a personal question. So what do you think about all the clones of Werkzeug? So is it like a threat, or is it annoying to you, or like you have seen like my tool, you have seen like a mentor showing his tool, and you probably know that there are like 5 other clones or so of Werkzeug. What do you think about this?
At the first, when we are doing FR8 and we are the only ones who had this kind of technology, I felt a bit in a competitive situation, and I was always thinking, oh, they never make it. And the first one who actually made a clone was Rick. And I said, oh, he'll never make it. But he did make it. And after that, I think that so many people are using this idea proves that the idea is good. And I like having good ideas. So I don't see it as a threat, I don't see it as a limitation, or I'm not annoyed by seeing people using this idea. Every time I see somebody coding something like this, I say, I was right. This is a good idea. Only good ideas get copied. There's another thing. It is not that easy to make something like this work right. So every time I see somebody coding this, I think he just wasted 6 months of his life to get it right. Or maybe just 3 or 2. I actually, in this early phase of FR8 coming out, and so many people trying to copy it, I said, we killed them. They'll never get it. It'll take them eternities to make it. And, well, that's a try. But it's all over, and I'm really happy that this idea gets so widely accepted. I'm sometimes, especially with you, very picky about the details, like drawing the lines and making it up or down or up, because my version is, of course, the best. And everybody who changes something didn't got the idea right. Especially Mentor didn't get one aspect of the stacking right. He is using lines every time he's splitting, but he should make this bigger operators. That would help a lot with the. You've seen this lines going everywhere. It could be better if you just would copy it more correctly. And by the way, flip it upside down because this is the correct way of doing it.
He's shaking his head.
Any other questions? I think that was good. Oh, one more.
So you started with Workzone, and then which is designed for a non-interactive experience, right?
Yeah.
Purely, well, maybe 90, very deterministic. And then you went into design Krieger using the same architectural methodology as you had with Workzone. Were there things that didn't map well in transition of using that approach from Workzone into an interactive format that you went back and said, oh, that was hard, or sort of burden points in terms of that transition to taking that paradigm, that architectural model, and moving into an interactive experience?
It doesn't matter. In Krieger, the Werkzeug was used for generating the content, and generating the content for a demo is exactly the same as generating content for a game. Maybe there are some more things we have to do, like placing respawn points, defining collision environment, this collision thing, and placing monsters and stuff. And well, this is all content creation, and content is a tool for content creation. One thing didn't went well. We used operators to design the menu. Every button is an operator, and there are if operators and stuff. That was an awkward way of doing it. I'm not saying that you shouldn't do it. I'm just saying the way we implemented that tiny little part was not the right thing. But like placing monsters, defining where the leg of the monster is, so that the walk operator knows exactly where the tip has to hit the ground. These are all things that can be very well done in the Werkzeug, and actually we're using, in my professional work, in 49 games, we are using the Werkzeug for doing exactly the thing, integrating all the data which is created in traditional way, non-procedural way, and making the whole world in it to export to the game. If it is the right way to break down game physics, to break down controls by operators and have some kind of visual language so that non-programmers can create, I doubt. But for content creation, it's great. It's also great for defining flow. If you have a conversion process in the games industry, you often have tool chains which are very long, which a conversion process has to go to various stages. And sometimes it's a little bit more complicated because you need multiple versions of the same data for different platforms or something. This stacking of operators helps define the flow, a very complex flow, which is too awkward to define in a script file or something, a batch file. So these are all good applications for operator stacking. But interaction has nothing to do with it. Interaction is not content creation. If it is, it's the wrong way.
Thank you. Right. Thank you, Chaos. That was amazing.